Hello students, welcome back. In this video, I will be talking about the topic of sparse matrix. So in the module 1 of data structures, we have a topic called as sparse matrix. So we will look at the topic in detail and some problems related with sparse matrix. First of all, you should know the definition of a sparse matrix. See, I have given the definition here. I think when you read it, it will make sense to you. A sparse matrix is a matrix in which, okay, it has more number of zero elements or a few number of non-zero elements. That means that, okay, it's a matrix. I hope you know how a matrix looks like. So here when you have the values, right, you will have the values, right? What it means for the sparse matrix is most of the values are zero. Okay, most of the values are zero and few there will be non-zero numbers like this. So this type of matrices are called as sparse matrix. Okay. So a matrix, you remember like this in the exam also. A sparse matrix is a matrix in which there are more number of zero elements and less number of non-zero elements. Okay. So I have given two examples. Can you understand what it means? See, there are two examples I've given. Okay. In this also, it's a 1D array. So here also three values are zero elements and the other two are non-zero. And in this example also, if you look at it, it is a 4 by 4 matrix. 4 by 4 matrix, 4 rows, 4 columns. So here also if you see most of the values are zero itself. So this is called as a sparse matrix. I hope the definition is clear. Now let us look at the abstract data type for the sparse matrix. See, most of them get confused what is this abstract data type. I'll explain it so that in an easy way so that you can remember. See, when you look at the home page of Google, for example, when you look at the home page of Google, okay, see here, you will have options like this, right? Here, I think you'll have images. Here, you have the search button and all those, right? So, see, what you will do is if I want to search for a pair of shoes, I'll write shoes over here and then I'll click on the search button, right? So, when I click on the search button, I'm getting the information about all the sites which have, information regarding that shoes that I've searched. Now, how do you think this happens? I am just looking at the button here. I'm clicking on it and I'm getting all the information. How does this work? How can the button give all the information? The idea is for every, for example, in this case, button, there is a hidden code for it. But you are not able to see. When you press this button that is search, internally there would be a search code that will run, but we are not understanding. We need not worry about this, right? Why do we have to know that there is a search code and all that? We just need to press on the search button and the information has to come. Likewise, in case of abstract data type also, this is the one which shows the functionality. See, when you look at the search button, okay, when you look at the search button, you click on it. Internally, what is happening, you need not know. So, an ADT sparse matrix is the one that shows the various operations that can be performed on a sparse matrix. Okay, various operations that can be performed. So you need not worry internally how this works. The name itself will tell you the function. See, there are first one is the objects. Okay, object means these values that you have. For example, in this case, there is 20, right? So this is one object. So it can have row number, column number, and the value itself. Likewise, there is functions. Functions means here the values are there. See, A and B. These are the two matrices. Then you can have max rows, max columns, and the values itself. Okay. Likewise, create is one, what is that? ADT. Likewise, transpose. I hope you know what is a transpose. If I have rows and columns in a given matrix, when I interchange the rows and columns, whatever I get, that is called as a transpose. Similarly, when I have two matrices A and B, I can add them. Similarly, I can multiply also. In the first year, you have learned about the program of matrix multiplication, right? So in that, you might have seen this condition. Do you remember seeing this condition? Okay. So these are the ADTs. I'll not go in depth because you just need to know what they are. Okay. So I think you are able to understand objects, functions, creating the matrix, transpose, matrix addition, matrix multiplication. Okay. So these are the different ADTs. Okay. So let me erase all the unwanted information from here and here as well. Okay. Next topic is representing the sparse matrix. How can you represent the sparse matrix? See, I have written the code for it. It's here I have to write declaration. So here you can have up to 101 values. See, each particular each particular value will have the column number, the row number, and the value itself for each term. In the term, you can have three things: a row number, a column number, and the value. And at the max, you can have up to 101. That is what I have given over here. You can have up to 101 terms. Okay, 101 values. So that is what. Okay, next is the most important thing, how to represent the sparse matrix. But before going to that, you need to know something about the triplet representation of a given sparse matrix. See, when you look at the sparse matrix, you might think, right, see, many values are zeros. Then what is the point? See this, if I consider this particular value, see, 0 and row number is 0, column number is 2. There 0 is told. 0 basically means nothing. But since I have a value, don't you feel that that particular location is allocated to a value which is nothing? I'm allocating that zeroth row and second column to a value 0. Don't you feel it is a waste? Okay, because it is 0, right? Why do we even need to store it? But we have that in value in the sparse matrix, so we have to allocate the memory. So is there any way I can represent the sparse matrix, but wherever zeros are there, can I leave it off? I need not to consider the ones with the zero value. So others I can consider. For example, in this case, it is 1 and 3. 1 and 3 here. See, not 1 and 3, 0 and 3. 0 and 3 is giving me 3 itself. So I can consider this one, right? Like this. Okay. So we have the triplet representation. Okay. So we'll represent. Okay. See, you need to have this table here. I have drawn this table and it has three columns. One is for the row number, the other one is for the column, and the other one is for value. So row, column, and value. Okay, now let us do the triplet representation. See, first thing is you have to, in the row, you have to write the total number of rows. Okay, total number of rows. In columns, you will have to write the total number of columns. And in the value, you have to write the total number of non-zero values. See here, total number of rows, how many rows do you have? 1, 2, 3, and 4. So, total number of rows are 4. Similarly, the total number of columns. So, 1, 2, 3, and 4. There are 4 columns. And how many non-zero values are there? So, 1, 2, 3, 4, and 5. 5 non-zero values. Are you clear? Okay. Total rows are 4, total columns are 4, and total non-zero values are 5. Okay. Then how are you supposed to do the representation? See, other values. See, you have to start row by row. Okay. You have to go row by row. you have to go row by row and you will have to write the row number and the column number of those non-zero values. So first non-zero value that I have is here, 4, right? So the value is 4. Write its corresponding row number and column number. So row number is 0 and column number is also 0, correct? Row number is also 0. Column number is also 0. So 0, 0, 4. Likewise, next one is 3. Next non-zero value that you have is 3. Its row number is 0. Its column number is 3. Similarly, 1 and 2, you have the value 1. Next non-zero value that you have is 2. Its corresponding row number is 2 and column number is 1. Similarly, 10, corresponding row number 3, corresponding column number is also 3, like this. This is how you do the triplet representation. We'll do for one more example that I have here. You can pause this video and do for this particular matrix and then check if it is correct or not. Okay, so here, how many rows are there? 3 rows are there. See, 1, 2, 3. How many columns? 1, 2, 3, 4, and 5. So 3 rows, 5 columns. How many non-zero values? 1, 2, 3, 4, and 5. Total non-zero values are 5. Then for each non-zero value, so you list out, okay, first non-zero value is 1, then you have 2, then you have 5, then you have 3 and 4. You have to go row by row. That is why. Then write each one's corresponding row number and column number. For 1, the row number and column number is 0 and 0. For 2, it is 0 and 4. Likewise, for 5, it is 1 and 3. For 3, it is, see, for this one, its corresponding column number is 1, row number is 2. So 2 and 1. Similarly, here 2 and 2. Now, are you clear with the idea of writing the triplet form? So you shouldn't get confused even for the exams, even for the campus placement, all these things, okay? So you have to, write this correctly. So you have to know how to write the triplet form. Are you clear with the triplet form? Shouldn't forget, always this should be in your mind. Next, let us do the most important thing, that is finding the transpose of a given sparse matrix. So row becomes column, column becomes row. That is what the transpose means. So for this one, I will have to do the transpose of the matrix. Okay, for this sparse matrix. So first thing is, I'll divide it into steps. Okay, so step 1 is write the triplet form of the matrix. Write the triplet form. Triplet form. For this given matrix, write the triplet form. So row, column, and the value. Row, column, and the value. Okay. So first you have to write the total number of rows and columns. Rows are 1, 2, 3, 4, and 5. Columns are 1, 2, 3, and 4. Okay. So rows are 5. Columns are 4. Total number of non-zero values. So 1, 2, 3, 4, 5, 6, 7, 8. 8 non-zero values. Now for each value, write the corresponding row number and column number. Okay, so yeah, let's do this. So the first one is 10. The first value that I have is 10. Its corresponding row number and column number are 0 and 0. Likewise, you have 40. Its row number is 0. Column number is 3. I hope you are following what I'm saying. Next, you have 11. 11. So its corresponding row number is 1. Column number is 0. So 1 and 0. Likewise, 22. So here it is 1 and 2. Then you have 20. So it is 3 and 0. 50. 3 and 3. Then you have two more values. One is 15. The other one is 25. Like this. For 15, it is 4, comma 1. And for 25, it is 4, comma 3. I hope it is clear, this triplet form. Once you have written this, then we'll go to the next step. We'll do the next step. Okay, now we will find the transpose matrix in step number 2. In step 2, I'll write the transpose of the matrix. Write the transpose matrix. See, what you have to do is, again, you will have to write the row number, column number, and the value. Row number, column number, and value. Now, transpose. Okay, so you will have to look at the triplet form and you have to get the transpose. What you're supposed to do is transpose. So, row becomes column, column becomes row. So, what you do is here, for the very first value, this is a total number of rows and columns, right? So, what you do is you interchange them. Because transpose, you're exchanging the row number and the column number, value remains as it is. Okay, value remains as it is. Next, you know that there are 8 values, right? So I'll write the 8 rows. So 1, 2, 3, 4, 5, 6, 7, and 8. Now what you do is, you have understood this step, right? So row becomes column, column becomes row. So 5 will be put in the fourth column number, and 4 row column has been put in the row number. I have exchanged basically. Then you have to consider the column of this triplet form. The column. So what you have to do is consider the smallest value among all these columns. See, in this column, you have different values, right? 0, you have 1, you have 2, you have. So you have to consider the smallest one. The smallest value that you have is 0. Correct? But 0 is appearing multiple times, isn't it? 0 is appearing multiple times. So which 0 to consider? So you will have to go in this order only. So first this 0, then this one. Like you're going one after the other. Okay. You're going one after the other. So first I will consider this particular one. Okay. So I will write that value. I'll write that value, but row and column have to be interchanged. Row and column have to be interchanged, but it will not make any difference because both are 0 and 0 itself. Correct? Next, what you have to do is check this one, this 0. So, interchange them. So, it is 1 and 0 here. So, here it will be 0 and 1. Corresponding value is 11. Then consider the next 0. So here it is 3 and 0. So 0 and 3 value is 20. So all the zeros are done. Then you check if the next digit is present. That is 1. 1 is here. 1 is here. So it is 4, 1. So it becomes 1, 4. 1, 4. Corresponding value is 15. Okay, all the ones are done. Then now 2. 2 you have here. So it is 1, 2. So it becomes 2, 1. Okay, 2, 1. So 2, 1, you have 20, you have 22. Then 3. So here, so it becomes 3, 0, 40. Then you have this one. So it is 3, 3, which is 50. And then you have 3, 4, that is 25. This is how you will get the transposed triplet form. Now convert it back to a matrix. Okay, so it says 4 rows. So 4 rows and 5 columns. So now put the values. Okay, 0, 0 is 10, 0, 1 is 11, 0, 3 is 20. So other value 0. Then 1 and 4 is 15. So rest of the values are all zeros. In 2, you have 2, 1, that is 22. Here I am. There are no other rows with 2. Then you have 3 and 0, 40. 3 and 3, 50. 3 and 4, 25. Like this. Now check if the values have interchanged. See, first row was 10, 10 0, 0, 4, 40. Here it is 10 0, 0, 40. See, can you see how the rows have become columns? So this is how you will find the sparse matrix. Sorry, the transpose of a sparse matrix. This is your normal method. One more method is there called as fast transpose method. You will have to find the sparse matrix. You will have to find the sparse matrix but using fast transport method. So this is used, and this is also commonly asked in the exam. I will take up one example and I'll show you how this works. Okay. See, sometimes what they'll do is they'll directly give you the triplet form. From the triplet form, you will have to do the transpose. Sometimes they'll give you the matrix itself. You will have to do the triplet form and then convert it. So we'll take one from each type. Okay. So I'll take one simple matrix here, 4 by 4 matrix like this. Okay. So I'll give some values. I'll give some values. I'll keep in mind that most of the values should be 0 itself. This is my sparse matrix. Now, I'll find the transpose of this matrix using the method of fast transpose. Remember, method is fast transpose. Fast transpose method. Fast transpose method. Okay, these are all very easy to score. You can easily score the marks here in this one. Okay, so first you write the triplet form. So now I think you know the triplet form, right? So shouldn't be a problem. Write the triplet form. So row, column, and value. Okay, so total number of rows are 4, total number of columns are 4, total number of non-zero elements are 1, 2, 3, 4, and 5. 5. Which row number and column number? First value you have is 4. Its corresponding row number, column number is 0. Then you have 1, 1. Value is 2. Then 2 and 0. Value is 1. Then you have 3 and 1. 6. Then you have 3 and 3, which is 5. This is how you'll write the triplet form, right? Okay. Now it is not using the normal method, it is using the fast transpose method. So in this particular method, before you do the transpose, you need to have these two arrays. One is total, the other one is index. Total and index. Array, okay, it's a 1D array. Now What is this and how to fill the values to it? See, what you do is, okay, it's a 1D array, so it will look something like this. But how many indexes should it have? See, what you have to do is, okay, in this particular triplet form, what leave the first column, other columns you consider, these columns. And in that, okay, in that you consider all the unique values that you have. See how many values are there? 0, 1. Then the other value should have been 2, but there is no 2. But the 2 is all present, right? 2 is present, right? So write all the indexes. The indexes go from 0, 1, 2, and 3. Write the indexes like this. Then write the indexes like this. Okay. So 0, 1, 2, and 3. Then in this particular column, check the number of times this indexes appear. These are all my shortcuts, okay, for you to remember. The terms might not be the exact ones, but you will be able to remember. See, how many times have 0 appeared in this? It has appeared 2 times, right? 2 times. So write 2 here. Similarly, how many times has 1 appeared? 2 times. So here also write 2. How many times have 2 appeared? Is there a 2 here? No. So 2 has appeared only 0 times, nothing. And 3 has appeared once. I hope it is clear. Okay. So this is how you will do the total. You have to write the unique elements 0, 1, 2, 3. Then you will have to count how many times it appears in this particular column. Okay. And you write the count. I hope it is clear. Let's do the index. So I have already written the index. See, like this. Again, 0, 1, 2, and 3. Like this. See, first one by default will have the value 1. So here 1 will be present by default. So here you write 1. Then the index of 1 is the result of the value at index of 0 index of 0 plus index of 0 plus the index of index of 0 plus total of 0. Index of 0 plus total of 0. Okay, so see here. This is index of 0, total of 0. So this is going to be 3. Are you understanding? So next one would be, I have to do for 2, right? Index of 2. So index of 2 is index of 1 plus total of 1. Index of 1 is 3 and total of 1 is 2. So it is 2 plus 3, which is 5. And here again 5 plus 0. So this becomes 6. I hope it is clear. Okay. You will have to see for the current value. See, for example, index of 3 is index of 2 plus total of, like this. This is a default value. It will always be 1. Okay. Now let us do the transpose matrix. Okay. I'll do the transpose over here. Additional steps are there, but that is how the method goes. So row, you also have column, then you have value. So 1, 2, 3, 4, 5, 6. So 1, 1, 2, 3, 4, 5, 6. Okay. Now, first thing is always you have to interchange the rows and columns. So that you do. So 4 and 4. So 4 and 4 value is 5. Next, what you have to do is, if you have to again consider this column only. This column is very important. Okay, I'll try to erase, but yeah. Okay, the entire line is also disappearing, so I'll keep it as it is. Okay, like this. Now, what you have to do is, which one to consider next? See, this is where the method is applied. What you have to do is, consider this particular column. Consider this particular column. See here. So I will consider this as 0, 1, 2, 3, 4, and 5. Okay, I'll consider it like this 0, 1, 2, 3, 4, 5. Now, what you have to do is, see, this is 0, right? First column you consider, value in the first column. It is 0, correct? Now you go to the index and check where this value is present. So 0. 0 is present over here, correct? Okay, 0 is present over here. Under that, what value you have? You have value 1. So, in the first column, in the first row of your transposed that particular matrix, or this particular table, transpose table, you place this particular row. I'll show it again. See, what you have to do is, first you have to consider, see, first you write the rows and columns here. Okay. Now, you have to consider this particular column here and the first value 0. That you have to identify in the index. So it is here. Under that, what value you have, in that number you have to consider and come back to this particular table and take that as a row number, and wherever this value is, this whatever value is there, that you will have to interchange and place. Okay, you have to interchange and place. I hope it is clear. I'll do one more. Don't worry. Just a second. Okay. So I hope you have understood. Now, once you put the value for whichever, you have considered this one, right? So that you increase by 1. So I'll use another color. So I will increase this by 1. Because next time I can't place it in that particular row. It's filled, right? So this will be 2. Rest of the values will be as it is. If you need not do this as a table, but sometimes the students get confused. So I usually tell them to make it as a table so that it's easy to understand. Okay. So 2 is increased, rest of the values as it is. Rest of the values as it is. So this is 3, this is 5, and this is 6. Next, consider the next column. So here it is 1. Are you able to see? Here, 1. Right? Now you come to that particular index. C1 is here. Correct? Under that, what number you have? You have 3. So this particular row has to be placed under index 3. So it is 1, 1, and 2. Okay. Then next thing what you have to do, whichever you have used, next time you increment that. So 3 has become 4. Rest of the values as it is. So rest of the values will be as it is. So 2, 5 and 6. Next again, consider this 0. So 0 is here. Its corresponding number is 2. So this value, okay, so it is 201. So it becomes 201. So it is 0, 2 and 1. So that is why this will now increase by 1. So this becomes 3. Rest of the values as it is. Okay, next consider 1. See this one, 1. Okay, next here you will have to consider 1 under 1 you have the value 4. So 316 will be placed under row 4, okay, with their values interchanged, row value and column value. Next is, so when you do that, you have to increase this value by 1. So this is 5. Rest of the values as it is. Rest of the values as it is. Now, can you tell me what to do for this one? It says 3. So you will have to go to 3. Under that, you have the value 6. Okay. I am getting the value 6. 1 second. Okay. Just let me check here. So it is 1 second. Is it 3 and 3, 5? 3 and 3, 5. Okay. So what you are supposed to do is check 3. 3 is having the value 6. Okay. But is there a 6 here? So what you do is you put it over here. Okay. So it is 3, 3 and 5 like this. Okay. So sorry, see here one mistake has happened. Were you able to identify here the mistake? I think I misplaced it here. See here. This value should be what? It should be the result of, see, this is index of 3. Index of 3 is index of 2 plus total of 2. Right? So index of 2 is how much? Index of 2 is 5 plus total of 2 is how much? 0. So it is 5 plus 0, which is 5. So this is 5. Let's. Okay. And it will be 5. So you have increased it. So this value will be 6. This values will be 5, 5 and 3. And this is the matrix you will get. Okay. I'll do one more example just so that you get a better clarity. Okay. I'll take one 3:3. I'll take a small matrix. Okay. So 0, 1, 2, 0, 1, 2. Values are 10, 0, 0, 15, 0, 0, 0, 0, 30. This is my matrix. So step 1, triplet form. Triplet form. So row, column, value. Okay. So total number of rows is 3, total number of columns are 3, and total number of non-zero values are also 3. 1, 2, and 3. Next, write the corresponding row number and column number of the non-zero value. First you have 10, then you have 15, then you have 30. Their corresponding row number and column number. Okay, so for 10 it is 0, 0. For 15 it is 1, 1. And for 30 it is 2, 2. I hope you have understood the triplet form. Now do the total and index. Okay, total. So you have to consider from here to here. So 0 is there, 1 is there, and 2 is there. So 0, how many times it is appearing? 1. How many times is 1 appearing? Only 1. How many times is 2 appearing? Again 1. Then index. Index also for the same 0, 1 and 2. I told you first value by default is 1. Here index of 1 is total of 0 plus index of 0. So index of 1 is index of its previous values. Index of 0 plus total of 0, which is equal to index of 0 is 1. Total of 0 is also 1. So the value is 2. So here the value is 2. Okay. Likewise, for the next one it is index of 2. So index of 1 plus total of 1. So which is 2 plus 1. So I'm getting the value 3. Okay. So I'll increase this. Now we'll do the transpose. Okay. So row, value and column. So first here interchange the rows and columns. Here it is the same. So no problem. Next, what you have to do is identify the, I think here it won't make that much sense, but I'll tell you the method because all the indexes are the same, right? So, but I'll tell you the method anyway. See, what you have to do is you have to look at this part, choose a dark color, this part, and in that you have to consider the first one. It says 0. So you will have to come to this table here. Wherever 0 is there, under that what value you have the value 1, right? So see 0, 1, 2 and 3. So it says 1. So under 1, you will have to place this by interchanging the row and column number. But here both are 0, so it doesn't make any difference. So it will be like this only. Okay. So when you do that, what is the thing I said? Here you will have to increase rest of the values as it is. Next, come to this part. It says 1. Go to this index. Under that what value you have, there you have to place. So 1, 1, 15. So this has increased rest of the values as it is. Next 2 you have. So 2. Under 2 you have 3. Under 3 you will have to place this 2 and 2. Okay, so this is how you will find the transpose. You can convert this into a matrix and check whether you are getting the actual transpose or not. You should get if your method is correct. So I have discussed about the sparse matrix in this video. So what is a sparse matrix? The sparse matrix ADTs, how to declare a sparse matrix, how to do the triplet form of the matrix, how to find the transpose of the matrix. One is your normal finding the transpose method. The other one is fast transpose method. In the exam, if they ask, I suggest you write this one. Okay, you take up your own sparse matrix and convert it and check if you're getting the answers. If there is any doubts, you can let me know. Okay, I'll do another video on some other topic and I'll see you. Okay, study well and take care.